So tonight we were going to continue uh, introducing little snippets of stuff that you're going to need for the project later in the semester. And tonight's kind of a fun one, probably won't be very long, but we're going to be talking about how to access AI functionality from a C# program. So what that will involve or include will be, I'm going to do a little bit of background. I find AI very interesting. I spent a lot of my master's and PhD research working with AI algorithms of one kind or another. My PhD doctorate, I involved some simulations, and I played around with trying to get the AI to learn what I wanted it to learn. So it's near and dear to my heart. Now, I can't teach you a full-blown AI class here because there are curriculum issues. We have in the state of Florida a standardized artificial intelligence course, and it has, in order to do justice to what the meat of that course is about, you also have to have a prereq, which is the data structures and algorithms class. So those are both probably more in the scope of a 4-year degree or, graduate level. You can take them as a graduate student too, if you haven't already then. But so this gets a lot deeper if we really wanted to get into exploring the different kinds of AI algorithms that are out there and trying to build our own and work with it and tweak it and optimize it and see what happens when we kick the tires and that kind of thing. That's a much deeper pit to wade into. We're just going to discuss some of the classical AI concepts that I find interesting, and then we're going to get into the mechanics of how we run one and interface with it from our C# program. And then we'll kind of try to relate that back to, well, great, that's all fine and well, but what would I use it for? And how is this any more useful than going to a web page and just typing in my query, because it's very similar. Okay, so jumping right in. Like it says, back when I was going to school, we had to walk uphill 5 miles to school and 3-foot snow, uphill both ways, all that normal stuff. Yes, I'm an old guy, and I had to do things the hard way in a lot of ways. But I don't begrudge that. On one hand, I found it very interesting to be in the academic world while a lot of these technologies were evolving. The last 5-10 years, there's been a real uptick in the level of hardware we have available to run these algorithms on, and the quality of the tool sets that we have out there available to us, whether it's in data mining or machine learning or artificial intelligence, pattern matching, classifiers, robotics, the whole works. There's so much more in the way of toolkits that you can download and use, as opposed to having to build your own screwdriver and build your own crescent wrench, which was you got to know those tools a lot better from the inside when you had to build them yourself, but you wasted a lot of time on the tooling rather than getting to the actual problem that you were trying to research or what you were trying to solve. So it's a good time to be alive, but I'm happy that I had to wade through that myself. So I guess one of the big things that I see today with the large language models being so prevalent, so popular, I guess is the correct word, is that, if your only tool is a hammer, everything starts to look like a nail. So you start using these AIs because they're sitting around, they're easy, right at hand, and why not use them for the problem that you've got? And they do a decent job. But I'll give you an example of something that I see with software development and trying to use these large language models. The other day I got into a conversation with one just to, playing around, experimenting. My wife was shopping for one of those medicine cabinets in your bathroom that are recessed into the wall. Well, I knew what the constraints were. It could be no more than, 16 inches minus the width of a 2x4. Can't be any wider than that. It can't be any deeper than the, depth of a 2x4. So, and I wanted it, about 20 inches tall. So I gave those very precise, exact constraints to my query, and it went out there and it said, oh, by the way, here's one, and by the way, it's all also made in the USA. You might consider this one. I click on it, and it's like, that's not even the right size. It's like 20 inches deep. And I told it, I said, oh, you mistakenly gave me an example that was the wrong size. And it said, oh, my bad, I'm sorry. Here's another one. Well, it was also the wrong size. And I kept going back and forth with it and never could get it to realize. But that's what they're good at doing. They'll make a guess, they'll make a stab at it. But if you're actually trying to build an agent that's going to go out and do your shopping for you, maybe you need a better one, or maybe that's not the right tool for you. So that's an example how these things don't work well. And I find the same thing in software development. I ask it for an algorithm to do something, and it doesn't sometimes give me back the correct algorithm. It doesn't work. It's not what I asked for, or it's buggy. Combine parts of, it's like when you see the generative AI give you a picture of a person and you can tell the person's hand has 7 fingers on it. It's like, dude, you're doing it wrong. It's the same thing. Sometimes these algorithms give you the average of what it knows, and it isn't what is going to work. It's not correct. So, that's just how it is with these. And just an example of how, don't fall into the trap of trying to use these things like ChatGPT for every problem, because they're not cut out for every problem. They're very good at what they do, or what you're asking them to do, but not precise. So a little bit about, one of the things that you'll learn in AI class if you start learning or, studying it formally is it brings up a bunch of philosophical questions. And I'm not going to go through a whole diatribe on this. I mean, I could spend a couple of lectures just going through all of the different research and thinking and discussion that's gone on over the past centuries. But a few of the highlights, there's this discussion over dualism versus materialism. And what it boils down to is the question we've asked for ages, do we have a soul? Right? Is there some spark of consciousness inside us that makes us unique and makes us special and gives us our free will? Or are we just a chemical-based computer? And, like on Star Trek, if you're going to get transported up to the Enterprise, is it really you? Or, did it create a copy of you, and now we got to figure out what to do with the original? Well, I guess we'll just, incinerate it so that now there's still only one of you, right? Are you able to create an exact copy with all the same experiences, memories, everything from that moment, and then maybe you start to diverge? Many sci-fi movies and other type of stories have been developed along this line, but what's going on here? So people have debated that for many years. There's another concept, the empiricism that it mentions here. John Locke has a famous quote that says, "Nothing is in the understanding which was not first in the senses." And that boils down for me to mean, some might argue that if you had the ability to create 2 universes and you put the same person in the same spot and gave them the exact same sensory experiences for the same amount of time, would you end up with equivalent people? In other words, if you could go back in time and not stub your toe on the desk, would you then become a different person? Or is there anything else outside of just what you've experienced? One thing that we always remark about when I had a herd of cows in Missouri, I would sit there and watch them sometimes, and people have remarked, are they just dumb animals? Or while they sit there chewing their cud, are they contemplating the nature of the universe? How deep does that well go? I don't know. Are we able to just come up with things on our own that are original, inspiration, in other words? Or are we just a product of what we sense? And this is kind of like the movie The Matrix. Are we in just one big simulation? And there was this funny line in one of the Big Bang Theory episodes where the guys are talking to Sheldon and they're like, so if we knew that you were a robot but you didn't, would you want us to tell you? And he said, I don't know, would something blah blah blah. And it's like, well, you might be that right now. If you don't know you're a robot, how would you discover you're a robot? Because if you're just a product of all the sensory input that your brain is collecting, or is there something else? And one of the things that I wonder is, I think about dogs and how dumb they must think we are. Because, it's like, dude, I smelled that pile of poo 20 yards away and you walked right up to it and stepped in it. How dumb are you? The dog knows it's there already because they can smell it. Or sharks, if you have a little cut on your finger, they can smell it a long distance away in the water, or taste it, I guess you'd say. What would our consciousness be like if we had that strong of senses? Or sensing magnetic fields. Do birds and other migratory animals, can they sense the magnetic fields and navigate based on them? I don't know. Here's another interesting one. One of the things that we humans are kind of restricted by is the 100-year lifespan, right? Since, I guess if you look back through genealogy back to Noah's time, everybody started only living to be about 100 years old. So what if we lived 1,000 years old? Would we have a better understanding of how time passes, and that would affect our consciousness and our interaction and our decision making? Like weather patterns. Would we not be so terrified of hurricanes because we'd know, well, every so often they're going to come along, because you can remember that far back and realize that everything's just cyclical. I don't know, but it brings up some interesting questions. And then the other thing is, if we are just a product of our senses and our experiences and our environment, how do you explain, a really good sheepdog has a litter of puppies, and inexplicably those puppies already know how to do a bunch of stuff, and they've sitting there in their mama's belly. They've never seen a cow, they've never seen a sheep, they don't know what they are until they pop out. But isn't it interesting how they already automatically know how to herd things and get them to go where they want them to with their body language? So to me, and they always told me as a kid that if you wanted really good puppies from a bird dog, you take the bird dog hunting while she's pregnant. And, the wives' tale was that you'll get better bird dogs that way, because something about that, the instincts are passed on to the puppies. I don't know. These are all interesting questions, and maybe somebody in your generation will figure out some of this stuff. But it's a very interesting philosophical category of discussions around AI. Another way to approach artificial intelligence in general is, what do you want it to do? What problem do you have for it to solve? One of the things I always said, that I'm not really that interested in artificial intelligence because I already know that I'm bad at stuff. I don't want to produce an intelligence that's just as bad at those things as I am. So when we start, I didn't go the course of, learning neural networks and things like that very readily, because that wasn't my goal. We've already got people to do that kind of work. Why would I want a computer to do that kind of work too? Now, there are reasons, they just weren't important to me. Like if you're going to send some agents on a spaceship to go to Andromeda, and it's going to be, you know, 300 or 400 years before the ship can possibly get there. But when it does, you want the agents on board the ship to be able to wake up and start acting rationally and do human-like things when they get there. Okay, well, maybe an AI-based solution is better, even if it acts like a human and is bad at what humans are bad at and good at what humans are good at. The longevity of it, it might actually be able to last. You can just put it in hibernation mode until it gets there and wake it up. So maybe it is useful. But last time I checked SpaceX's calendar, they don't have any ships going to Andromeda anytime soon. So maybe that's not as helpful. So do we want a C-3PO in our house? That'd be really cool. But do I want it to forget to take the trash out every Thursday or Friday morning? I already do that. That's not helpful to me. So on the other hand, do I want it waking me up? Mark, you forgot to take the trash out. Get out of bed. Go take the trash out. Do I want something following me around, kind of like the mother-in-law robot, you know, correcting every mistake that I make? Is that useful? Is that desirable? And then let's say we do have, you know, the AI gets to a point where it's able to solve some of these philosophical questions for us. Do we want to know the answers, or do we want to learn them ourselves? So that bears thinking. What are our goals? Do we have a particular problem, in which case we're going to try to find the flavor of AI in our toolbox that's well suited to that? You know, goes along again with picking the right tool for the job. You know, then we think, you know, we know what life's like right now. We can view, you know, read about history of where we've come from, but where are we going? You know, it'd be really nice to have an AI in my car that says, I really need to go to the grocery store, but I need to check up on my email. So AI, you drive the car to the grocery store while I read my email. Okay, that'd be interesting. So like it says, solve this problem, build that item, hand me that tool, which I always thought that would be a fun one for these astronauts in space. They're sitting there in this big bulky spacesuit trying to fix some gear on some solar panel or something. And maybe they just tell the robot, hey, can you go get me that tool and bring it back? You know, maybe that would be helpful in space. But then we get to the question, well, now they're starting to, you know, over in Ukraine, they're starting to come up with these drones that go over and kill people. Do we like that? Or destroy that factory or blow up that tank? You know, that gets in a little bit more fuzzy gray area. I'm not sure we all agree that we like that kind of behavior. And the next question is, we get to ethics. Can we humiliate or abuse a robot? You know, I want to keep this PG, but, you know, we do have people talking about in CES and other places these sex robots. Is that an ethical way to use a robot? I don't know if you guys saw this podcast was mentioned in the news, but there were, okay, so I call these individuals young and have way more money than common sense. But in a way you could just say, well, hey, good on them for having the resources. You know, they've done something right to make a lot of money. They can do whatever they want to with their money, right? Some people buy a Lamborghini. These guys buy a $70,000 robot. But it kind of acts humanoid. And so these guys in this podcast, they're like bullying it.
Yeah, they were like pushing. I seen it on the news. They were like pushing it back and forth and whatnot. Yeah, but it was kind of cool because I never even knew that like robot was like it was a thing. And then
Yeah, those robots
like,
are
sitting down,
like those Boston
yeah.
Dynamics robots. They're
Yeah.
amazing. They can do the acrobatics. They can
Yeah.
flip and jump over things, and they're getting to be pretty amazing. But is it even possible to abuse something? I mean, it's like breaking your lamp in the living room. It's my lamp. If I want to break the lamp, you know, are we going to start considering that an ethical problem, that people humiliate or abuse machine-based You know, is that, we don't consider it a life form? But, I mean, it's, you could definitely say that it's in bad taste taking something that's that humanized, and, you know, it makes a lot of people uncomfortable.
It's hard to classify because like it doesn't have feelings, but like it's like they're still pushing it around, and it looks it's like a little person, you know.
Yeah,
Like it's hard to classify. Like I'm both ways with it. Like I don't care, but at the same time, it's like what is the point of it, you know?
yeah. Yeah, and I think that, you know, I would put this in the category of, is playing Grand Theft Auto, and, you know, some of the things that they allow you to do or encourage you to do or require you to do in the game, is that leading us to be our best self? I guess maybe is the best way to ask the question. Or is it reinforcing things that, what's that old Chinese proverb about, you know, we each have a good dog and a bad dog inside us, and they're always fighting for control. Which one will win? The one that you feed more is the one that'll win, right? Well, maybe this is feeding the wrong dog. But it's good questions to ask, but I don't know that I have an answer one way or the other. But it's going to come up because that's where robotics is heading. Is we're going to have very humanoid-looking robots very soon. Then we get a little bit further down the road, and maybe companies, you know, you own a company, you fire your CEO, and you have a robot as the CEO, and the robot's telling everybody what they want, what their assignment is. Are we okay with that? Would you want to work for a robot? Instead of having it work for you, would you want to work for it? I mean, probably, like all of us, it depends on how much job pays. You know, but are they going to treat us okay? Are they going to, you know, are we going to have a union to make sure that our rights are protected from our robot overlords? And do they care what the union thinks, right? These are going to be ethical questions that you guys in your generation, you're going to have to ask and answer, most likely. So, and what is an AI-based intelligence or robot? What is it going to find valuable in us? Maybe we should start encouraging people to develop those skills that our robot overlords are soon going to find valuable. I don't know. Good questions. So going back to a little bit of the history and the evolution of this stuff, there are so many different flavors of AI that have been, some of them are very primitive, that were developed in the early days when we started automating this stuff with very poor hardware to run it on, so not very much capacity, not very much memory or very fast CPUs or anything to deal with it, to the large language model stuff that we have that's plug and play nowadays that we're going to get to later. But there are so many things in between. I can't list them all for you, and most of them, like when I took my AI classes and I was playing around with this stuff in my research, I had to learn a lot of these and what they did and how you could use them and configure them or build them if you needed to. But a lot of that stuff I've forgotten. So even if I could come up with a definitive list, I don't know that I would remember what they all are. Like PCA, I know that's principal component analysis. It's a statistical method for taking a set of points in n dimensions and having the algorithm tell you, oh, you know, if you look at it on this dimension, all these data points, they line up. And so this is your trend. This is what this data represents. So it's a really cool technique if you need that kind of thing. But there's so many of them. I'll mention a few of them. One of the early ones is this program called Eliza. I don't know if anybody's ever heard of it. All it is it is a command prompt or a console application, and it says, how are you today? And you say, fine. And it says, tell me more about how you feel fine. Well, it's nice weather outside, and I feel pretty healthy. Tell me more about feeling healthy. Well, you know, I have had this problem with my ankle, but now I'm doing okay. And I mean, it just keeps pulling out keywords, And it has behind the scenes a big nested if statement. It says, if the sentence contains this word, then emit this canned response. And you could have 5 of those if statements, and the conversation could be very repetitive very quickly. Or you could have 500 of those if statements, and you might even start thinking like, wow, this is a real conversation with a person on the other end. But that's what Eliza was. It was just the how are you feeling today, and would begin a conversation with you. And you guys could build that right now without any other programming classes, because it's just a big nested if statement. If the string they entered contains this word, then print this on the screen. That's all it is. Well, we get kind of down the road on that kind of technology, and we have these medical diagnosis algorithms that do a similar kind of thing, a little bit different. They say, well, what are your symptoms? Well, my head hurts, and there's blood coming out of my right leg, and, and I got this big, huge knife sticking out of me. You enter your symptoms, and then it says, well, okay, you've got this one, so I can narrow it down to this group of things. And in that group, you've got this one, so I can narrow it down to this group of things. And it just keeps whittling away until it says, oh, you've been stabbed. But it just kind of does the same kind of thing as the ELIZA program does, but on steroids, and helps you from a vast array of symptoms that you could have, give you a pretty close diagnosis to what you might be suffering from. That's another kind. The iRobot, the vacuum that we've got in our houses, they do search algorithms. But there's an algorithm called, it's more of like a reactive agent, where it's not very smart, what you would call smart. The algorithm just says, move forward an inch and suck. Did I get any dirt? If so, move forward an inch again and suck. Did I get any dirt? And keep doing that. When I get to, did I get any dirt, and it says no, it says, okay, we'll turn to the right. And it's a very simple algorithm. And what we would say is that has the emergent behavior from those few simple rules: do something, react, do something, react. It can, in essence, clean your whole house from those few simple rules. And the early robots came out with very simple logic and would do some weird, crazy stuff once in a while. But the newer ones have completely different algorithms, much more evolved, much more subroutines that says, wow, I found myself in this situation. I'm going to switch to a different way of solving that problem in this situation. And they've, tested it with thousands and thousands of hours, and, it's far beyond my ability to guess how they do it anymore. But those are pretty neat. Another one is the model-based. So one of the things that people have done over the years is they'll take an employee and they'll say, well, I'd really like to automate that employee's job. Maybe it's somebody that assembles boxes. So what they do is they have somebody observe that person or what they do. It's like, well, they grab a piece of cardboard, they make a mark, they fold it on that mark, then they turn it, and they basically just list all the things that they observe that person doing, and then try to train a robot to do the same thing, to mimic them. Well, sometimes it works and sometimes it doesn't. There's an old movie from the 80s called Starman. I don't know if anybody has seen that. But basically there's this guy from outer space who came down and is, hanging out with this woman, and he wants to drive the car. So she lets him drive the car, and he's doing really well, staying within the lines and doing all this stuff. But then all of a sudden, they're driving down and the light ahead of them turns yellow, and he floors it. And she's like, what are you doing? What are you doing? And they get through the light with people honking at him and stuff. And he said, oh, well, yellow means go faster. Because that's what he saw her or other people doing. It's like, well, they're rushing the light, Well, so observing what somebody does and then just blindly imitating them maybe is not always the right way to get to a good solution. But that's model-based agent algorithms. Ant colony optimization is a really cool one. So ants leave a pheromone trail everywhere they go, and the scent of the pheromone indicates and communicates to other ants what the what the point is of the ant being on this path. So if they just found a big old sugar cube and they're heading back to the queen, they're going to lay out one kind of pheromone. Anybody else comes to that path, they're going to say, bingo, we want to get on this gravy train and help out. Problem is they don't know whether to turn right or left, so sometimes they turn right and sometimes they turn left. So sometimes they go back to the queen with no sugar. Sometimes they go back to the sugar cube like they wanted to and get some sugar. But then what they do is they repeat the same path. The cool thing about that is the original path will zigzag and go up and down and over stuff and around and through and blah, blah, blah. It's a really zigzaggy path. But then over time, as dozens of these ants follow the same path, it'll occur to one of them to take a step to the left. And it leaves a little pheromone trail that cuts a corner. And here and there, they start cutting corners. And it's like you have a string laid on the floor that you just slowly pull from both ends. And the path over time gets straighter and straighter and straighter and shorter and shorter and shorter until that's the shortest path between those 2 points, between the sugar cube and the queen. And so people have written software to mimic that algorithm, and it's actually over time, without a whole lot of smarts, you're just following the trail. It does a pretty good job of optimizing the plan. So that's kind of cool. Swarm theory is another one. There's Michael Crichton, the author that wrote Jurassic Park and those books and stuff. Sphere. He's done several different ones. He did this one called, was it Swarm? I think was the name of it. Anyway, he did one based on swarm theory. But it's, again, this emergent behavior idea that if you build these really tiny, simple agents that don't have very much intelligence, but you make 1,000 of them and you let them all interact, they end up coming up with some pretty interesting behavior as a group. And I guess the idea would be like a flock of birds. You watch a flock of blackbirds as they're getting ready to migrate, and wow, some of the cool designs and patterns and things that they come up with as this blob of birds morphs and churns and flies this way and that way. Sometimes it splits into two, sometimes it joins back up. It's amazing the artistic acrobatic behavior of these birds acting as a flock, where any one of them, it's just a bird, just flying from tree to tree. So that kind of stuff can be, they're with the mass production of drones nowadays, they're experimenting more and more with how can we make drones do interesting things as a group. Classifiers, that's a classic algorithm type. The idea here is you have supervised behavior with labeled data. So you have, let's say, 1,000 fish, and you take 900 of them, and as it comes through, you show it to the AI, and you say, this is a trout. Okay, you get the next one. Okay, this one's a bass. And after a while, the AI starts to realize itself the properties of each one of those fish that leads to it being classified as what you told it in the training data to do. Then you get to the end, and the last 100 you have it do itself, and you grade it on how well it did. And now you've built a classifier that you could set in a factory, and it can sort your fish for you. That's the idea behind it. Have you seen what was the name of the movie or the show, Silicon Valley, I think? And they have I haven't watched a lot of them because honestly I can't get past the language, but there's some funny episodes on there that I've seen the clips from where the Chinese guy is building a phone app that identifies hot dog or not hot dog. So you show it any kind of food and it will tell you whether that food is a hot dog or not. So I don't know, that was pretty funny. But it's the same kind of thing. You're building a classifier, and that's a really accessible technology that's been out for quite a while that you can pretty much build yourself. Evolutionary algorithms are built around the idea that you build a population, let's say 100 individual agents, and each of the agent has different properties of it. Well, you throw them out in the environment and you let them run, and then you take the top 10 performing agents and you combine them, split them into two groups of 5, let's say, and you take half of this agent and half of this agent and you combine them together to make a new agent, and you replace the population with the combinations of those things. As the idea is it's modeling what happens with DNA when you create a baby, right? And then you continually repeat that, create a new population, adapt that, mutate a little bit, have random changes that you throw in there with you combine parts of the two, but then you randomly tweak it a little bit so that you get a little bit of changes over time. And then you let it run for many, many, many generations. And just like with the ant colony optimization, it can be surprising how it leads to having a population of individuals that perform really, really well without a whole lot of understanding why they perform better. And like I said, it goes on and on and on and on. Every one of these terms that you see up here, you could Google and go down a rabbit trail of what the heck is this, and what would I use it for, and how would I build one if I needed to. So it's fascinating. If it's one of those things where if you think that we're done developing this stuff, I would say there's a huge amount of potential out there. One of the things that happens in computer science research is that these little fads pop up and it sucks all of the funding out of the room and gets a lot of attention for a while, and then it'll kind of dry up. And then another fad will pop up over here and all the funding will go chase that. So right now, the last couple of years, these large language model algorithms have been getting a lot of attention and have been very popular for good reason. There's been huge advances in them. But there's many other things out there that we could be spending our effort on. And that's one of the games you play as a computer scientist and as a researcher is, where is the area that I feel like with my skills and what my interests are, where I can make the biggest impact pushing forward the bounds of knowledge in one of these areas. And many times researchers work on something for a year or two and they realize, yeah, that was kind of a dry well. I think I'm going to go ask my advisor if he's got any ideas for something related that might have a little bit more potential, and you bounce around for a little bit, and then eventually you find one that, oh wow, this is really cool. I discovered something new, or I used this in a different way and got better results, and you publish your dissertation on it, and boom, you get a PhD. So the good thing about us is we're in one of the science fields, and without poo-pooing other colleges on the campus, getting a PhD or master's degree in something like computer science is still much more of true value to society, I guess, than some of the other, again, fad-based degrees that have come along, where you can basically go out and give a survey to 200 people and write up your results, do a little statistics, and they give you a piece of paper. Yeah, I don't find that very interesting. But computer science is very ripe for progress still. The other cool thing about it is now we have these LLM-based AIs in our toolbox. And so if you want to go down the road of trying to push forward the bounds of knowledge in one of these other areas, you got your own AI tool sitting there helping you answer your questions, and it can really push you forward faster. I remember, I don't know if I've told this story before, But I remember when I was at Microsoft, I had the opportunity to have Gary Kasparov on campus one time, and this he was working with IBM on Deep Blue, and they asked him, who the best chess player was, a human or a computer, and he said, well, I'll answer a little differently. The best chess player is going to be a human assisted by a computer, because the human is going to have the intuition to sense that there's a trap coming up and creatively think of reasons why you would and ways to exploit the situation and get out of the trap and maybe work it to their advantage. Whereas they're more effective at playing chess if they don't have to stop and analyze all of the moves down that path. If they can have a tool just tell them, hey, what's the best move? What's the end result of that path if I go this way? So the intuition, instincts, plus the raw data crunching of the two together would make the best player. So anyway, so now you guys are essentially able to be researchers in whatever area you want to be, assisted by some really cool algorithms to help you move forward. Okay, yeah, so like I said before, this is not an AI class, even though it may seem like I got typically long worded there as I go down my little rabbit trails. But we're going to take a shortcut here in this class. We're going to use the AI and not build it ourselves. So essentially the approach we're going to take is somebody out there has already taken some of these packages, figured out how to get them to run on a Linux machine, created a Docker container for it, and put it out there in Docker Hub that we can take advantage of. So we can leverage their work. So that's the first thing that we're going to do is create a Docker container that is running a large language model engine. The second step is, now that we've got the engine running, we need to tell it, hey, I want you to consume this model that somebody has already trained. And the way these models work is there's dozens and dozens of them out there. Some of them are tailored to a specific domain area, like a manufacturing plant. Some of them are trained on other areas that are very different, and some of them are very general. They're good at all. Some of them haven't been trained very much, and you get, your results may vary, but don't rely on it too heavily, especially if you stray off the path where it's been trained. Others have been trained for thousands of hours and are very robust. And the size of the model varies accordingly. If you want a very powerful model, then you're probably going to be sacrificing memory because you're going to have to download a large model. But we're going to try to hit something small, something that's really easy to consume, that's more general purpose. And I think for our purposes, it's actually not so bad that it's not perfect, because we're going to have it help play our game for us. And it's okay if it makes a bad move once in a while. That's probably fine. It'll be interesting to see what it comes up with. So yeah, I describe this as standing on the shoulder of giants. Other people have come before us and done a lot of the heavy lifting and made it nice for us to just be able to consume this stuff. So we've got the Docker container running the engine. We've got the model downloaded and it's been digested and is available to accept queries and give responses. And then we need to have the ability to modify our C# program so that we can make those queries and get the answer back and be able to process it. So the other cool thing about it is, I don't know if you've played around with them and said, I want you to answer this question as if you're Albert Einstein. And he responds in a German accent, or I want a picture of a house in some style, like early colonial architecture, and it returns it, with that flavor. It's able to tailor those things. So like if you said to this AI that we're going to have, you're a player in an adventure game, and I want you to have a little bit of an Old English flair to your responses, it'll do that. It'll happily try to modify the responses. Or you can say, all your responses, you should pretend that you're a pirate. You'll get pirate grammar back. So that might be interesting to play with. Yeah, so here's the command. It's up here on the screen for you. You can, take a picture of it and use it. But the great thing about this is these two commands you can just run and boom, a few minutes later you have an AI up and running on your machine that you can query, you can interact with. A couple of things I'll point out here. A lot of this stuff is just boilerplate. When you use Docker and you run it in detached mode, it's just running in the background, waiting back there for you to interact with it. It's doing its own thing. The second thing is this port number. Somebody, not me, came up with that standard port number for this Ollama Docker container, but that will be the port number that we will communicate with or over when we communicate with this program. So you'll need that when you write your code. Just remember, you can make it whatever you want to, but you'll have to, if you want to deviate from this, then your mileage may vary. But I know this will work. The second one is getting the Llama 3 model. That's where you can play around if you want to research what other models are available and play with one of those instead. Like I said, I tried this one out, and I know as of this time, on this day, on this date, it happens to be an active model that's available for you to download. Reserve the right to tell you later that, hey, guess what? Llama 3 is now Llama 4 or Llama 5. So, you might have to, if this one goes away all of a sudden on us, you might have to do some Googling to figure out a newer model or a bigger model or a smaller model or whatever, your goal is to do. But I think this is pretty darn cool and it's not over the internet either. If you've got your laptop or one of our desktop machines in here or something else, you can run these two commands on a machine that has Docker installed and have a local instance of an AI up and running that you can interact with, which I find amazing and pretty darn powerful. Obviously, the better CPU, the more memory you have, the better it's going to perform. If you're running on a laptop with not much memory and a slow CPU and no GPU, then you may have to wait several seconds to get an answer back. The exec here that I gave you is assuming that you're going to run in CPU only mode, but the resources that I will give you later, you can Google, there's a mode, if you have like an NVIDIA graphics card in your PC, you can look up what the alternative, it's just an extra parameter on this to say, by the way, feel free to use the GPU on my machine, and that'll speed it up, give it more horsepower. So that's it. That's the two commands, and you're up and running with a working AI, large language model that you can interact with. Okay? The next thing is, how do we interact with it from our C# program? Well, there's a package. So Microsoft has already added to their .NET library extensions. Now these are currently beta. Maybe they'll not be beta down the road at some point, but currently they're beta extensions. But it makes it pretty darn easy to interact with this. So you just need to add this to your packages list in NuGet in your Visual Studio for whatever project you're building. So you would go out and you'd create a C# console application like we've been doing, and you would just go to the menu and go to the NuGet package manager, search for the Ollama, find the one with that name there on the screen, and you would add it to your project. Now it's available for you to use. And so here's how, it's a little bit of code. I'm not going to go through it in detail, but I'll overview it for you because you just basically copy and paste this to your program. We're going to create a new connection to that. Notice here the 11.434 is running on localhost on that port. So that's how you're going to configure your client object to be able to connect to that. and I've also told it this is the model I want to interface with. So it kind of goes with the previous command that I issued to Ollama. I told it, by the way, go get this model and download it. This is very finicky in my experience. If you have a typo here, or you haven't downloaded and told it to digest that model yet, you'll just get blank answers back when you try to ask it questions. So if you're doing this and you're sending queries to it and you're not getting anything but blank responses back, double check that your Docker commands are correct and that you're connecting on the right port and that you're referencing the right model. Because I had, problems when I didn't get those things matching up as I was experimenting. We're just going to keep looping, and what this loop does is it says, ask the user for a question, get the question, send it to Llama, get the answer back, display it on the screen, and loop around and ask her another question. It's just a simple chat bot. And so it'll work, and you can play around with it, and you can ask it questions, see the answers, ask it questions, see the answers. The cool thing is it's never going to tell you, oh, sorry, you used up your quota, you need to put another $20 in the slot to be able to continue using it, because it's running on your machine. You can unplug from the network. It's self-contained, it's all on your machine. So it's at your disposal. So I think that's pretty cool. And that's really it. So like I said, we've taken lots of shortcuts, standing on the shoulder of giants, 2 Docker commands, add a package to your project, put this code in it, send it chat messages, get responses back, and you've got a program that's able to interface with your AI. Now, what are we going to do with it? Well, I keep updating that project for the game assignment. I put a bunch more detail in there. As it gets closer, it gets more and more in focus, and I'm able to provide more context as we go through lectures like this. I think the next one that I want to do is talking a little bit about, correct me if I'm wrong, you guys in the beginning C# class, you did Windows Forms applications primarily. I thought that's what I remember seeing. And in here, I've said, okay, well, good, you already know that. So I've not dwelt on that, because it can be a little bit tedious every time I come to class to have to spend time building up a Windows Form application just to illustrate my point. It's a lot more approachable and quicker to get to the point if I just create a simple console application and start illustrating, adding the classes and manipulating them. So that's what I've focused on. But I want to get back to that. So you can imagine taking this code that I've got here on the screen and building a Windows Form application with an input box where you ask them to answer the question, you hit the send button, you send the message off with this code here on the screen, and when you get the message back, you populate a text box on your Windows Form. It works exactly the same thing for a chatbot function, but is Windows Forms based instead of console based. It's perfectly fine. And so, I'm starting to get closer and closer, adding that detail to the assignment so that we can integrate a lot of that stuff. But the other thing I want to talk about a little bit is some of the data structures like lists and things that we have available and how to manipulate those. That, again, building up to feeling like you've got all the tools that you need to jump in and give it a crack to do the assignment that I want us to do. So again, we went over some common branches of AI, showed how to start a Docker container and how to interact with it from C#. So that's pretty much going to conclude the lecture today. Any questions about anything we've talked about so far? I know I didn't give a demo, but I'll leave that for you guys to do to actually prove it to yourselves that what I put up here is working. Yeah.
In the Windows Forms, is it going to be like a specific way you want us to like design how you want the text box and everything, and how it's going to look on the Windows Forms, or is it just going to be up to us pretty much?
I'm much more picky about what I like to see.
Okay.
than in telling you what it is that I expect to see. So, how about we will address that when we start looking at the actual assignment. Because I came from the days when Windows applications adhered to very strict Windows user interface guidelines. So I have a lot of pet peeves along that. When I see an application that breaks the rules, then it kind of irks me. But it's been so long since I focused on that carefully that it's hard for me to just sit down and off the top of my head list what they all are. But a lot of it's common sense. I like for the borders of things to line up. I like for you to have uniform space between things. And then the other stuff that gets more subtle is tab order. I like for you to go to the extra step when you've got 8 or 9 controls on your form to go in the menu and say, I want to set the tab order, and click through each of your controls on your page so that there's a rational tab order if you just keep hitting tab through the controls through the page for it to cycle around. And usually, like if you have an OK cancel on your form, those need to be last in the tab order. But yeah, I mean, unless you're doing garish things like setting bright neon background colors, or just or another thing is like making the text really big. As long as my whole thing used to be, when I would tell people what I like to see is run Microsoft Word, open some of their dialog boxes, and even if you can't figure out what the requirement should be, mimic what they're doing. Because these things have been user tested in labs, watching what people do, why they click on the wrong things, what confuses them, what helps them, for years. Thousands of hours of developer hours have gone into doing those things in what somebody considered the best way. So if we can get a lot from just mimicking what they do. So Word, Excel, they have lots of dialog boxes that you can look and see how they gathered that. What kind of control did they use? Did they use a checkbox or a radio button for that? Did they use an edit box, or did they do a drop-down list? And just kind of mimic what you see them doing, and you'll probably be okay. So that's the general stuff, and we'll get more specific later.